Good day, students. On this clip, we're going to be going over an example on how to find the derivative of logarithmic functions. So this is going to be part one of the multi-part installment. So just add part one here. So what are we going to do? Let's write down the question. So find the derivative of the following. Find the derivative of the given function. And then a function under consideration is y equals x to the third e to the x times 2x plus 3 divided by 3 to the ln x times x plus 2 squared. Okay? Now, if I wanted to apply the standard procedure to find the derivative of this, I'll have to use the quotient rule. You remember what the quotient rule is, right? If you have u over v prime, it's basically vu prime minus uv prime over v squared. Okay? In this problem, when I'm looking for u prime, I'm going to have to use the product of three functions to find the derivative of u, which is the derivative of the numerator. So if I have f, g, h prime, I'm going to have to use the rule f, g, h prime plus f, g prime h plus f prime, g, h. And then when I'm looking for v prime, I have two functions, f and g, and I have to use the product rule, f, g prime plus g, f prime. Okay? When I put all these together into this product, into the quotient rule, it becomes a mess and really complicated. It's doable, but it's very complicated. So using logarithmic differentiation is a very easy and easy way to execute the derivative, to find the derivative of this function. Okay? So how do we go about doing that and avoid making a mess using the quotient and product rule? Well, to do that, all we simply do is we're going to take advantage of the logarithmic properties. So before we can do that, we'll start out by taking the natural logarithm of both sides of our equation. Okay? So I'm going to take the natural logarithm of y. Natural logarithm of y on the right side equals, and then do the same thing to the right side of the equation, the natural logarithm of this entire function, x to the third e to the x times 2x plus 3, the whole story divided by 3 to the ln x times x plus 2 quantity squared. Okay? Now, we're just going to keep bringing down the left side along, so the left side is going to be the natural log of y. Now, to simplify the right side, I'm going to first of all take a look at, use the product property, actually the quotient property of a logarithmic function. Okay, I'm going to use the quotient property first, and then I'll use the product property. So what is the quotient property? If you have the quotient of two functions, so if you have the natural logarithm of f over g, it is the same thing as taking the natural logarithm of f minus the natural logarithm of g. Okay? So it's basically the same thing. So if you look here, we have the numerator and the denominator. So taking the natural logarithm of the quotient of these two functions is the same thing as taking the natural logarithm of the numerator, which is ln of bracket x to the third e to the x times 2x plus 3 minus, notice the minus, you have to subtract the natural log of the numerator and then the natural log of the bottom, okay? Minus the natural logarithm of the denominator, which is 3 raised to the natural log of x times x plus 2 quantity squared, okay? Alright, now to break it further, you notice we have a product of three functions here and a product of two functions here. We're going to now make use of the product property of logarithms, which is that the natural logarithm of the product of let's say two functions, f of two functions or more, basically is the same thing as taking the natural logarithm of the sum of the respective functions. So natural logarithm of f plus the natural logarithm of g. And if you have h, you just add the natural logarithm of h. Okay? So we have the cubic function times the exponential function times the linear function. And on this side we have the exponential logarithmic function times the quadratic function. Okay? So here we're going to be adding 3 functions, and here we're going to be adding just 2 functions. So breaking it further, on the left side we have the natural logarithm of y equals the natural logarithm of x to the third plus the natural logarithm of e to the x plus the natural logarithm of the quantity 2x plus 3. Notice what I did here. These products became the sum of the logarithmic values of each expression, each of the products here. Okay? Minus, same story here, the natural logarithm of 3 to the ln of x. I have to put the parentheses here, very careful. Plus the natural logarithm of x plus 2 squared. Okay? Alright. Now we notice that each functions have, well, some of the functions have exponents within, right? They have power. So we can also take advantage of the power property of logarithms. Okay, so let's write that up here. The natural logarithm of, let's say, a function f raised to the nth power is the same thing as you can bring down the power, and it becomes a coefficient. So it's the same thing as n times the natural logarithm of the function. Okay? So what does that mean? It means that using this property, I can bring down this 3 to the front right here. I can also bring down this x to the front of the natural logarithm since it is a power. This has no power, so I don't need to bring out any power. This power here is actually a function, so I can bring down this entire function to the front of this natural logarithm. And then this power is 2, I can also bring it to the front of this natural logarithm right here. Okay? Alright, let's go ahead and apply that. We're going to have the natural logarithm of 3 ln x plus x times the natural logarithm of e plus the natural logarithm of 2x plus 3 minus the natural logarithm of x. This whole power becomes what you're going to be multiplied by the coefficient of ln of 3. Now, see this minus right here? I'm going to distribute this minus to this plus, since this is encapsulated in a parenthesis. So this becomes minus 2. This power comes to the front, comes down, times the natural logarithm of x plus 2. Okay? Alright. Oh boy, I left out the y, so there's a y over here. Okay, so now I have simplified the function considerably, and this is a very easy function to differentiate, as you'll see momentarily, okay? Now, how do I differentiate this function? Well, I'm going to use the implicit differentiation to differentiate both sides of this function. And then wherever I have y, I'll just substitute the original value of y at the beginning. Okay? So let's differentiate the left side. We know the derivative of natural log is 1 over x. So the derivative of ln y is 1 over y times y prime. Alright, let's differentiate this. The derivative of ln x is 1 over x, so we are going to have 3 times 1 over x plus the natural logarithm of e is simply 1, so this is just 1. Natural ln of e is 1 since they're inverses. So the derivative of x is 1 plus, now I have to apply the chain rule here. The derivative of the natural log of 2x plus 1 is 1 over 2x plus 3 times the derivative of the inner function, the linear function 2x plus 3, which is just 2, minus, here you might think to use the product rule, but that's not necessary because this is a constant, so we just factor that out. And then we differentiate ln x, which is 1 over x. Okay? Minus, factor out the 2, the derivative of ln x plus 2, we use the chain rule again, 1 over x plus 2. And the derivative of x plus 2 is just 1. You see how easy that was to differentiate? So after rewriting it, you can differentiate it in a snap, okay? So let's just dress it up. So we have y prime over y equals 3 over x plus 1 plus 2 over 2x plus 3 minus ln 3 over x minus 2 over x plus 2. Okay? Alright, now we're asked to find y prime or the derivative, so I need to isolate y prime. So in order to accomplish that, I need to multiply both sides by y. So multiply the left side by y, and then multiply the entire right side by y also. Okay, so these two cancel out. I'll be left with y prime equals, to write this, 3 over x plus 1 plus 2 over 2x plus 3 minus the natural logarithm of 3 over x minus 2 over x plus 2. Instead of writing y, remember what y was at the beginning of the problem? You see this value for y, that's what I'm going to substitute for y over here. Okay, so it's going to be times the original problem, which is x to the third e to the x times 2x plus 3. And this whole story divided by 3 to the natural logarithm of x times x plus 2 quantity squared, close that bracket, and there goes your final answer. Okay? So there you have it. Alright. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. You can also share the contents of this video with your friends via Facebook or Twitter. More videos can be found on mathloveserve.com. Thanks again and have a wonderful day.